Welcome back to the third video. If you're new to this series, go back and watch the first two videos and I'll wait for you here. Okay, this video is going to cover the next 5 days of this adventure kit, and in each of these 5 days we're going to be concentrating on this new component, a little keyboard. So let's get straight into it. In day 11, we're going to learn how to talk to the keyboard and get back the value of whichever key we've decided to press. And you can see here by looking at the layout, we're not using the breadboard at all here. We're simply wiring pins 2 to 9 on the hero board to the pins on the keyboard. There's basically 8 wires, and the keypad is a 4x4 layout for 16 buttons. The keypad is going to be telling the hero board which key has been pressed in terms of row 1, 2, 3, 4 and column 1, 2, 3, 4. And it sends each of those values across 4 wires. Let's look at the program for day 11. You can see right at the top there are 2 includes. This brings in the library that we need to communicate with the keypad. So the first thing we need to do is add that library to our Arduino / hero board. To do that, we go up to Tools, Manage Libraries, which brings up a list of all the libraries available for download. If we go to the search box and we type in keypad, we get a list of all the libraries involved in keypads. We need to skip all these Adafruit ones and go down to K. We want this basic keypad library. Now, if you haven't already installed it like I have, you would select the version. 3.1.1 is the latest version as of this video, and then you click install, and then that will incorporate the library. So let's go back to the program. We're defining our keypad as 4 rows by 4 columns. We already talked about that. And we're also defining what the characters are that each button represents. So we're going to use a standard numeric keyboard, 1, 2, 3, 4, 5, 6, 7, 8, 9, star, 0, pound. And in the 4th rightmost column, we're going to use A, B, C, and D. Then we're going to tell the program which pins on the hero board represent the rows, pins 2, 3, 4, 5, and which represent the columns. Then we instantiate the keypad, telling it the data we've just defined. In the setup, all we're going to do is initialize the serial monitor, and the loop is very straightforward. All we're going to do is poll the keyboard, and if a button is pressed, we're going to print that out to the serial monitor. So let's download this to the hero board and test it out. So the first thing we're going to do is open up the serial monitor, and now we're going to press some keys on the keyboard. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9, which you can see are showing in the serial monitor. We have star, 0, and pound. And then in the rightmost column, we have A, B, C, and D. Very easy demonstration of how to use the keypad. In day 12, we're going to expand the capabilities of the keyboard. This time, we're going to generate a different sound depending on which button is clicked on the keyboard. And for this, we've wired up this little speaker. The speaker is simply wired up to ground and pin 10 on the hero board. So let's have a look at the program. The program is extremely similar to that of day 11. Right at the top, we include the code definitions for the keypad library. We once again define the keyboard as 4 rows and which pins are columns versus rows. All of this is the same. The definition of what each key represents is the same. This is the new piece of code where we're going to define a frequency tone for each button. So as we press the keypad, it's going to sound very much like the old touch tone phones that made a different tone on each button. In setup, we simply define the serial monitor, and in the loop, we poll the keyboard like we did before, and this time we use the row and column value to find the tone of the frequency to play through the speaker. We're going to send the value of the key and the frequency to the serial monitor, and then we're going to play the tone over the speaker for half a second, and then turn the sound off and keep going. So here we are with the program downloaded, and let's try out the keypad. And as you can see, the key values and the frequencies are being displayed in the serial monitor. That's a very simple lesson we've learned today, but now we know how to use a keyboard and how to use the sound speaker. There's an extra part to day 12's lesson, which they called a side quest. It's a little program to download, and I'm not going to tell you what it does. You'll have to buy the kit and try out day 12 to see what happens. But it's fun. Here we are on day 13. There's no changes to the circuit for this day. In fact, we're not going to use the speaker, but we're going to leave it on the circuit board for tomorrow. We are going to be using the keypad, and today is purely a lesson in programming. We're going to deal with passwords. Basically, we're creating a secure access to our ship's control systems using the keypad. So let's look at the program. Much of it is the same from yesterday, so I won't go over that again. And let's scroll down to the setup routine. In here, to the serial monitor, we're going to print a couple of instructions. Basically, we can set a new password by using the star key, and we can attempt to log in using the pound key. So what we do in the loop is we scan the keyboard. And remember, we're not going to play any sounds this time. And if it's a star, we need to authenticate first. So there's a function here we call called unlock mode. And it prompts us to type the password. And then it basically collects every key we type in and compares it against the password that's defined at the top of the program. And if you get it wrong, it tells you so. And if you get it right, then you successfully logged in. Coming back to the loop, if you've successfully logged in other words, unlock mode returns 0, then we are told that we are authorized And at this point, we can enter a new password, which is essentially the same as when we logged in using the password, except that this time we're changing the password in the code. And if we get it wrong, then it tells us access denied. If we type a pound, then we use the same function to basically authenticate ourselves using the existing password, and now we're logged in. It's fairly straightforward, so let's download it to the board and see it in action. So if I reset the board, you can see that in the serial monitor we have the instructions. So let's go ahead and press star. Now we're told to type the password to continue. The password is 0000. We're told we have successfully unlocked the device, and now we can enter a new password. Let's make it 1, 2, 3, 4. Password successfully changed. So now I've hit the pound key, and now we're going to try and log in using our new password. So if we type the wrong password, 6, we're told already that access denied. Let's try again by hitting the pound key. And now let's type the proper password, 1, 2, 3, 4. Device successfully unlocked, and we are authorized. So it's a very simple program that allows us to authenticate using a password or reset the password. That's about it for day 13. Let's move on. Here we are at day 14. This is probably our most complicated circuit to date. Ostensibly, we're using the same circuit from last time in the sense that we're dealing with the keyboard and we're going to use password control. Except now we have a couple of extras to help us. We've got our speaker wired up, if you remember that from an earlier lesson, and that's going to play a series of sounds to tell us whether we successfully logged in or not. And we also have, if you remember this circuit again from earlier, where we have 3 resistors lined up to the multicolor LED, and that's going to provide us visual clues as to how successful we are at logging in. This is the circuit. Let's take a look at that program. This is probably the longest program we've seen to date as well. So it starts in a very familiar way with the Keypad include files. And then we're defining some pins from the board. We're setting up the sound buzzer on pin 8 and the LED on pins 9, 10, and 11. Here is the familiar code about defining the keypad, 4 rows and 4 columns. And here is the definition of the characters that will be returned when you press those buttons. This is the same as previous days. One thing that has changed is that 2 of the pins to the keyboard have been moved along. There's a reason for this that's a little too complicated to go into in the scope of this video, but it's because we want the LED pins to be in the middle of that previous keyboard range. So then we have a very similar function that you remember from last time about unlocking the keyboard, essentially logging in. Except this time we're bringing in the sound and the LED. So if you get the wrong password, it will call this play error routine. And if you successfully log in, it will call this play success routine. And during the time that you are logging in, it will flash the LED blue. Here is the play success and play error routines, which basically makes a series of buzzing noises on the speaker. And here's a function we've seen before for sending color values to the multicolor LED. You define the red, green, and blue values. And in the setup routine, we set up the pins of the LED as output, and we set up the serial monitor as always, and we put up the user prompts on the serial monitor. Then in the loop, similar to the previous day, we get the key from the keyboard, and we decide if it's an asterisk, we go into change password mode, and for that we need to log in first. And if we fail to log in, now it will turn the LED red. If we successfully log in, it will turn the LED green. Wait a while and then turn it off again, and now we're ready to enter a new password. And this is all the same as before, except that we're going to be flashing the LED blue during the process again. And then once we've successfully changed the password, we set the LED to green. So we're basically using the LED as color prompts for our login process. And then there's a similar thing if you choose to log in using the hash key, using red and green to indicate whether we've successfully logged in or not. And that is the program. It's definitely a lot more complicated, but we've seen much of this before in previous days, and we've been building up to this. So let's see it running. Let me start by resetting the board. And you can see that it turns the LED white and then off to indicate that everything is ready. So let's try and log in by pressing the hash key, and let's type the correct password, which is 0000. And you notice it flashes the LED blue, plays a tone, and gives us the cute little sound when we've successfully logged in, along with the green LED. Let's do that again and do the wrong password. Oh, and we get the red LED. So here we can see feedback using light and sound, and we don't even need to look at the serial monitor. And I could go through the process of setting a new password, but it'll work exactly the same way. So this is a demonstration of how we can use everything we've learned in the lesson so far. Done. So as per the previous videos, day 15 is a creative day, just like day 5 and day 10 were. So there's nothing to show here. This is where you're prompted by the video to go and do your own project. So I'd like to hear in the comments below if you are indeed working on your own project. I'd love to see what you're getting up to. Meanwhile, if you're enjoying these videos, please subscribe, please like, and I'll be along in a week or so with the next video. Hope to see you soon.